So we're going to be going through the lecture here, and we're going to be looking at different examples of chemical reactions and trying to help understand what are some characteristics of the different types of chemical reactions. And so here we have aluminum plus copper chloride gives us copper plus aluminum chloride. And so one way you can break this down is that you see that on the reactant side we have a element plus a compound gives us element plus compound. And so here you see we're on the reactant side, we have an element and a compound. On the product side, we have a new element and new compound. And what we notice is that the element on the reactant side displaces the metal ion in the compound, and we get a new element and a new compound. And so this would be a single replacement reaction. Because again, the elements on the reactant side displaces in this case, since it's a metal, displaces the metal cation in the compound, and we get a new element and new compound. Now here, if we wanted to, since this is redox reaction, since the element is a metal, the element is what's going to be oxidized. So here, aluminum is the reducing agent. Because aluminum is going to get oxidized. So if something is oxidized, it's going to be contained in the reducing agent. Next, the metal, since we're dealing with a metal here, metals displace cations. And so the cation in this other reactant is copper. We know that copper is going to get reduced. So it's going to go from a +2 here to a 0. Whereas aluminum went from a 0 to a +3. And so since copper is reduced, copper to chloride is the oxidizing agent. So again, if you're dealing with metals here, the metal that's the element is oxidized. The metal cation in the compound is going to be reduced. So the compound on the reactant side is always going to be your oxidizing agent. And again, that's when you have a metal as the element in the reactant side. So again, this is a single replacement reaction. Now we'll look at another example. So here we want to determine what type of reaction. It doesn't necessarily need to be redox. So let me scratch that out here. We just want to know what type of reaction the following is. And so when we look at this reaction, there's a few things here. We notice that the reactants are aqueous compounds. So we have two compounds which are aqueous. And we form, as products, a compound that is aqueous and a compound that is solid. And so notice here, there's no elements involved in this reaction. And when you see that there's no elements involved in this reaction, like elements as reactants or products, that may be a good indication that redox hasn't occurred. And so if we check here, the way we know redox hasn't occurred is because you see here on the product side, or excuse me, the reactant side, we have sulfate. We have sulfate on the product side. Here we have chloride. We have chloride on the product side. So there's no change in the type of anions on the reactants and product side. Likewise, on the reactant side here, barium is a 2+. Here, barium is a 2 plus. Here, copper is a 2 plus. Here, copper is a 2 plus. And so the characteristic that may help show you that this is not redox is that the anions are the same on both sides. So if the anion is the same, that means those elements in that anion did not change oxidation number. And then when we check the charge of the cations, you see they did not change either. So this is not a redox reaction because there's no change in oxidation numbers. So again, the characteristics, we have two aqueous compounds. We switch the two cations. That's what's happening. So barium and copper switch. And we get two new compounds, and one of the compounds is a solid. And so this would indicate a precipitation reaction because we start with two aqueous compounds. We form two new compounds, and one of the compounds is a solid. So this would be a precipitation reaction and also a double displacement reaction. So here we have another chemical reaction. We have ammonia plus oxygen gives us nitrogen monoxide and water. So again, if we write this out, we have some compound and plus oxygen gives us two compounds. So we have some compound plus oxygen gives us two compounds. Now what we want to look at is here, if we look at the compounds, we see that both, or excuse me, look at the products, both products have oxygen in it. And the other element in the products comes from the compound in the reactants. So we see we have nitrogen monoxide, we have nitrogen here. On ammonia, we have hydrogen, we have steam. So the products are oxides of ammonia. So we have nitrogen monoxide and steam are oxides of the elements in ammonia. And then we have this reactant oxygen. So what we're doing is we're reacting something with oxygen to get oxides as products. And so since we're reacting something with oxygen to get oxides of products, this would be a combustion reaction. So again, we're reacting a compound with oxygen and we get oxides of that compound. And so here, ammonia would be referred to as the fuel. So when we combust ammonia, we get oxides of ammonia. And so since this is a combustion reaction, we know that the ammonia, which is the fuel, is going to be the reducing agent, because the fuel is always the reducing agent in a combustion reaction. And so that tells you that something in the reducing agent gets oxidized, and it's always going to be the non-hydrogen component. So nitrogen is oxidized. So again, the non-hydrogen component in the fuel is always oxidized. The fuel is always the reducing agent. Likewise, oxygen is the oxidizing agent. And oxygen is always reduced. So again, we have oxygen, we have a compound, we get oxides of that compound. So we get nitrogen monoxide and steam. So since we have oxygen as a reactant and we get oxides as products, this is a combustion reaction. And ammonia is the fuel, and the fuel is always the reducing agent. Oxygen is always the oxidizing agent. So nitrogen, the non-hydrogen component in the fuel, is always oxidized, and oxygen is always reduced. So here we want to know what type of reaction this is. And then again, if we write out the general form, we have an element plus a compound gives us an element plus a compound. So here we have an element plus a compound gives us an element plus a compound. And so redox has occurred because we have two different elements on each side of the reaction. On one side it's chlorine, on the other side it's bromine as elements. And so what we're noticing is that the chlorine comes in, removes the bromide, and then we get bromine and sodium chloride. So since chlorine displaces the bromide, this is a single replacement reaction. So again, one element replaces another. So this is single replacement reaction. So just like with the other one we had with aluminum and copper, here we have a halogen that's an element and a halide. And so the halogen displaces the halide and we form a new element and compound. Now, since this is a halogen, it doesn't follow the same guidelines as to what is the oxidizing and reducing agent. So what happens is the element, in this case, when your element is a nonmetal, you see here chlorine has a charge of 0, chloride has a charge of -1. So here chlorine is reduced. So in this case, chlorine is the oxidizing agent. And chlorine is reduced. And so it's the opposite of what we had on the previous single replacement problem when we had a metal. So when you have nonmetals, such as in this case, the element is the oxidizing agent, the compound is the reducing agent. So to confirm that, we see that bromide is a -1 here. Elemental bromine has a charge of 0. So this means that bromine or bromide is oxidized. And so sometimes you may read in textbooks, this is actually called a subgroup of single replacement called halogen replacement. So again, when you have a halogen as an element and you see it displaces another halogen, the elemental halogen is always going to be the oxidizing agent. The compound is always going to be the reducing agent. And it's flipped if the element is a metal. So these are the characteristics of a single replacement reaction involving halogens. So in this series of exercises, I give a bunch of different reactions of single replacement reactions, and we want to know, do these reactions, will they occur or not? So we have a series of single replacement possibilities for single replacement reactions, and we want to know, will these reactions occur or not? And we give you the activity series. So again, you don't have to memorize the activity series, you just have to know how to utilize the activity series. And for halogens, just to let you know, halogens, we're talking about F2 Cl, I shouldn't say 2, I'm just talking about the halogens in general. FCl, Br, and I. So as you go up, this decreases in activity as you go down. So we do consistent with that, decreasing activity. So fluorine is the most active halogen, and then it decreases as you go down. So in the first example, we have iodine plus sodium chloride gives us sodium iodine plus chlorine. And we want to know, will this reaction occur? So we have iodine as the elements, and we're displacing chlorine. So for this reaction to occur, iodine has to be more active than chlorine. So if we look here, chlorine is here, iodine is here. So since iodine is less active than chlorine, no reaction will occur. So this reaction will not occur because iodine is less active than chlorine. It's not going to displace the chlorine or the chloride from the compound. So no reaction. Next, in this example, we have shown zinc displaces tin. So we got to go to our activity series. We find tin, which is right here, and we find zinc. Since zinc is higher than tin, zinc is going to displace the tin. And so this reaction will occur because, again, zinc is more active than tin. It will displace tin from the compound. Next, we have, in our third example, we have iron plus aluminum fluoride. We want to know, will iron displace aluminum from the compound? And so we find aluminum. It's located here. We find iron. It's located here. So since iron is less active than aluminum, no reaction will occur. So the iron will not displace aluminum from the compound. And that's because iron is less active than aluminum. The fourth example, we want to know, will potassium displace silver from silver nitrate? So we find potassium is located here. We find silver. Since potassium is more active than silver, it will replace silver or displace it, and you form potassium nitrate and silver. So again, if the element is more active than the metal in the compound, the reaction will occur. Next, we have calcium, and we want to know, will it displace the hydrogen from the water? And so we look at calcium, we look at hydrogen, and since calcium is more active than hydrogen, it will displace from water. And another characteristic about water is only those elements that form soluble hydroxides will displace water. So if you remember, soluble hydroxides are your group 1 and heavier group 2 elements starting with calcium. So only those metals will displace hydrogen from water because they form soluble hydroxides. And so this reaction will occur. So let me write that over here. We're talking about water here, we're not talking about steam. And again, this is because they form soluble hydroxides. So you remember from your solubility rules, group 1 and heavier group 2 elements or cations will make soluble hydroxides. So that's why the group 1 and heavier group 2 elements will displace hydrogen from water, because they form soluble hydroxides as products. So for the next one, we want to know when we react, well, the F we have to disregard because F will not react because nickel 2 chloride will not react with water because nickel 2 chloride is soluble. So this one we just have to scratch out. It's no good. Because it can't be, salt will not react with water. And lastly, we have sodium and calcium chloride. We want to know, will sodium displace calcium? So we find sodium. You see that calcium is above sodium. Therefore, no reaction will occur because calcium is more active than sodium. So no reaction will occur because calcium is already paired up. So again, this is how you use the activity series to determine whether a reaction will occur or not. And for those that involve water, now it's water, not an acid. If it's an acid, then you can use the activity series. But with water, you have to remember group 1 and heavier group 2 elements will displace hydrogen from water. So the problem with F is that this was a compound here. So this was an aqueous compound. And since it's a compound, it's not going to react with water. It has to be an element to react with water. So if you put nickel 2 chloride in water, it's just going to sit there and it won't react. So for single replacement reactions have to occur, one of the reactants has to be an element. And so since nickel 2 chloride is not an element, no reaction will occur. So in the last series of reactions we're going to look at, some of these are going to require us to identify the reaction. Other ones we're going to have to identify the products of the reaction. So in A, we have N2H4 plus O2 gives us NO plus H2O. So again, what you should kind of look at first is, we have oxygen as a reactant. So that's a good indicator here. And you see that we form oxides of the other reactant, which is N2H4. So N2H4, we get oxides of nitrogen and oxides of hydrogen. And so since oxygen is a reactant and we get oxides of the compound, of the reactant that's a compound, this would be called a combustion reaction. The next example we have, if we look at the characteristics of this reaction, we have two reactants gives us one product. And so the characteristics of this reaction show us that we only have one product that comes from multiple reactants. So this would be a synthesis or combination reaction, either name you want to use. Because again, we have multiple reactants gives us one product. And since one of the reactants is an element, you know that redox has occurred. So we have a compound plus elements gives us one compound. Next, we have a element plus a compound gives us a compound plus an element. And this should be aqueous So an element plus a compound gives us compound plus elements. This is the characteristic of a single replacement reaction. So you see here barium replaces the hydrogen, dislodging the hydrogen as hydrogen gas. And so this is a single replacement reaction. And again, barium is one of those that form soluble hydroxides. That's the group 1 and heavier group 2, starting with calcium. In the fourth example, we have two aqueous compounds. Gives us another aqueous compound and a liquid. And what you should note here is that if we look at the reactants, one of the reactants has hydrogen listed first in the formula. So this tells you that that reactant is an acid. And the way we know it's an acid, there are two things here. One is the hydrogen in front of the the first element in the formula, and the second characteristic is that it's aqueous. So these two together mean that you're dealing with an acid. So again, the first element generally in the formula, if it's a hydrogen, of course, obviously water doesn't count, but for other ones, you see an element listed first as hydrogen, you notice that it's aqueous, then it's going to be an acid. Second thing we notice is that the other reactant is a hydroxide, and a hydroxide means it's a base. And so since we have an acid and a base, you see that we produce a salt and water. And so this would be called an acid-base reaction. Again, the way we know HBr is an acid is H is listed first, and the reactant is an aqueous. Second, we're dealing with the other reactant is a hydroxide, so we have an acid and a hydroxide. That's an acid and a base. We're going to get a salt and water. Now, the last four examples, we have to write the products of these reactions. And so here we have fluorine, which is an element, and we have sodium bromide, which is a compound, and we have two products that are produced. So since we have an element and a compound and we have two products, we can probably be fairly certain that one of these products is going to be an element, one is going to be a compound. And so with that, that tells us it's going to be single replacement. So what we're going to do is we're going to replace the bromine or the bromide with a fluorine. And so our two products would be Br2 and sodium fluoride. Now, when you write these products, you have to write them correctly or they won't be counted correctly. So what do I mean? I mean, when you write bromine, it has to be written as a diatomic. You can't just write Br. That's not correct. So it's Br2 plus NaF, sodium fluoride. For these, you don't have to include the physical states. As long as you put the products, the right formula, that's mainly what I'm looking for. In F, we have lithium chloride. It's a solid. We get two products. So here we're starting with one reactant. We get multiple products. So this is going to be a decomposition reaction. And since it has two products, we need to break this down into the elements. So we're going to have lithium plus chlorine. But you got to remember, chlorine has to be written as a diatomic. So it'd be Li plus Cl2. In G, we have some compound plus oxygen, gives us two products. So the fact that we have oxygen and another compound, this is a good indication that we'll be dealing with a combustion reaction. And so for combustion reactions, if we're dealing with a carbon and hydrogen-based fuel, our products are going to be oxides of carbon and hydrogen. So it'll be CO2 and H2O. Because again, we're dealing with oxygen and another compound, and it gives us two slots. We can fairly certain that this is going to be a combustion as well. Now back in E, fluorine goes with sodium bromide, or displaces bromine or bromide and sodium bromide, because fluorine is more active than bromides. Remember, as you go down the group 17, the activity decreases. So fluorine is the most active halogen. It's going to displace the less active halogen. And finally, in our last example, we have calcium plus nitrogen gives us one product. And so the fact that it gives us one product means that this is a synthesis reaction. Now, when you write the one product, you have to write it correctly. And so here we know that calcium is a solid, but as a ion, calcium is +2. And nitrogen here is a gas, but as an ion, nitrogen is -3. So the formula for this should be Ca3N2. So again, you have to write the correct formula of the product. Yeah, so let's the recap. E is a single replacement. So when you're writing the products, again, you got to look at how many possible products they're telling you that this reaction will have, and from that, you can determine what the products will be. The second important thing is make sure you write the formula of the products correctly. Because if you put Li plus Cl, for example, that's incorrect. It has to be Cl2. So you have to remember those elements that exist as molecular elements, such as the diatomic molecules, tetraatomic, octatomic, etc. So again, always try to identify the reaction first. That'll tell you what types of products you'll have. And for the first four that we did, we kind of looked at the key characteristics of what's occurring to identify the type of chemical reaction.